Hi, Gil from Testing Gil here. Today we're going to talk about another aspect of test design, speed. In this series we're talking about different aspects of test design, but we need to remember that we need to think about them collectively, not separately as we're discussing them here, and then compare their advantages and their costs and find the best design that we should use. Speed is something that we don't give a lot of attention to, which is kind of funny because we all want answers very quickly. But there are human reasons we probably don't compare speeds. If you're running a test manually, which is a design choice by the way, we'd probably notice if one alternative takes minutes and another one takes hours. In that case, the comparison is very easy. But most of the time, it will not be that easy because the length or the speed of the test is from the same order. It will feel the same to us in terms of speed. For an automatic test, it's the same, but the scale changes. It's from milliseconds to seconds to minutes. But again, the same feeling applies. If the test of two speeds is from the same order, we'll experience them the same. The thing is that we're not going to run a test once. If we're going to run it many times, there's going to be a compounding interest on the time we wait. We understand that. This is why we automate tests. We understand that we're going to run tests over and over again. We feel that the order of magnitude of manual tests is a lot bigger than the ones of automated tests. We can even feel we can calculate the saved time on automating the manual tests. We can talk about the speed of a single test, but most of the time we're going to run them in groups or in suites. When we're running the tests locally and cherry-picked, we're going to get the results very quickly. But if we're running them in suites that take hours to complete, we're going to get the results in the end. By the way, this is why you want to evaluate and manage your suites according to speed. We don't want to wait for quick test results for a long time. The test results could have been here already if they weren't attached for the one giant slow test. So, assuming we have different designs that answer our questions in the same way, we'd probably want to pick the faster ones. And there are ways to speed things up. The first thing that pops into our mind is parallelization. We can run multiple tests in parallel. This way we can cut down the entire suite running time. Okay, the giant slow one will slow things down, but we'll get the other results faster. So concurrency is one way to speed things up, and how many tests and which tests run in parallel is a design choice. However, it may not always work, or not work the way you expect. In our Bigger Better bookstore, we write tests about adding and removing books. We have one test that looks like this. We add a book and get its data, and we validate that the book was added successfully. Now, here's another test. In this one, we add a book, remove it, and try to get the details. In this one, the expected result is that the get would fail, because we deleted the book. If we look at these tests separately, both of them seem correct. But what happens when we try to run them in parallel? Here's an example of what can happen, although it can be hundreds of them. When we run in parallel, we can't control which call happens when. The order of the calls can get mixed. In this case, the calls intertwine. When we get to the delete API, it does delete an instance of the book. But because of the order that happened, there's going to be two instances. But the final get API will not fail, because there's another instance of the book in the system. The problem, of course, is this is not predictable. It is not reproducible. Today, the calls may run in one order and tomorrow in another. Remember predictability? There's a video talking just about this. So concurrency can speed things up, but our test design needs to take this understanding of how things shall work into account. There could be other ways to speed things up, but they may not answer the question that you actually wanted to answer. Here's an example. In our Bigger Better bookstore, everything is bigger and better. So we're running things on bigger and better cloud servers. Our test runs on containers and virtual machines, pretty similar to how things will actually run in production. This, of course, comes with its own set of problems. The setup is more complex. Tests run in a more unpredictable way because things need to be synchronized, and it's hard to synchronize these things, as we've already seen. So all these things are about predictability, but let's focus on speed. One of the issues that we come across in distributed network systems is that they have network delays. Whenever there's a hop between machines, the answer is not instantaneous. These delays compound and make the test run longer. So here's a thought. What if we run everything on the same machine? So I bet that when you're thinking about it, first thing that pops into your mind is this is not going to run like in production. And the second thing, if it's not running in production, what do the test results even mean? Well, it's not running like in production, but it does neutralize all the effects of the network delays and the synchronizations. It makes the tests run faster, so we can get the results faster. But what do the results mean? Well, depending on the results, if the tests pass, that means that the paths through the code actually passed, and we have a confidence that it will work in production. If the tests fail, that means there's probably an error in our code. The bug is there, and we can find it, debug it, and fix it. And we know that if we fix it, it will work in production too. If the tests fail, they will point to a problem in the code. We're not going to fail on an environment issue. You see, we've neutralized all the disconnects and timeouts that can happen in a distributed system. So if something fails, it's probably in our code. This is a good thing, because if the problem is in our code, we can find the bug, fix it, run the test again and see that it actually passed. So no, it's not like running in production. So we'll need tests that actually simulate running in production. But we can get the result to the question, does our code work, earlier and faster and more reliably. We can play with a different structure of the system to get similar answers. We can use mock databases or mock API calls or use in-memory databases, get the same answers but more quickly and more reliably. All these choices are design choices. They can help us get better answers quickly. After running those tests, we can run fewer, slower tests. Those will help us build confidence that not only our code works, but it would probably work in the environment of production. And how cool is that? Speed is important, because we'd like to have answers sooner. With proper design choices, we can both run our tests more quickly, get the results earlier, and make the decisions based on the results. And that's why we run tests, right? Thanks for watching. If you like this video, like, subscribe, and share this video, and watch other videos on this channel. And in the comments, tell me about how you run tests concurrently, only to confuse yourself and don't know what the results actually mean. Until next time, bye-bye.